Good morning, good afternoon, good evening, everyone, depending on when you worked. And a special welcome to this edition of ENERGIZED SAGA 5, hosted by MWE. My name is Margarido Quive. I'm a subsea engineer working in the energy or oil and gas company. And I will be the moderator today and facilitator for your section. So today, this session will be hosted by MWE, and I would like to talk about MWE first. MWE, it's a platform where women can work together and bring their energy to identity areas of action and empowerment. MWE wants to change the narrative of Mozambique and to contribute to the sustainable development of our country. We strive to create equal business opportunities. Also, MWE is a platform that normally used to targeting the SDG 5 and SDG 7. SDG 5, it's about the gender equality, where women and men are treated and perceived to be equal. MWE is focused on new opportunities for inclusion. And also the SDG 7, it's for affordable and clean energy. And that's about what we're going to talk about today, the clean energy. Today, this section is about LNG production. With this section, we'll be able to understand what is LNG. LNG stands for liquefied natural gas. And with this section, you will be able to understand how is it created, how is it transported also, and how it's going to our homes and our industries.
Before we get started, I would like to do some housekeeping. So let me share my screen and then we can move on. So the meeting will be recorded. So if you miss a spot, if you miss a line through this meeting, you will be able to watch it later. This will be available from next week or maybe 2 weeks later. And also, this section will be divided into parts. First, we will have the presentation, and then we will have the Q&A section. So I would like to highlight you some point here. Below on your mobile phones, on your PCs, you will find the Q&A button below, and also you will find the chat button. So I really encourage you to use the Q&A when it comes to make questions, and also we will be able to see all the questions, and then we'll answer for those questions. And also on the Q&A, please don't use the anonymous. Please use your correct name, and then you can send us the question. On the chat, I would like to encourage you to give us your point of view, to give us some ideas, to give us some suggestions if you want. And for this one, you can really address to all the panelists, or maybe everyone if you want to share this to everyone. So by default, all attendees are muted in order to avoid the disturb the panelists also. And if you want to give us some suggestion, if you want to say something, you can really raise your hand, and then I will be able to unmute you in order to give your insights. So we have a really special session today lined up. Why special? Because we have two Mozambican women that will share their experience, that will share their journey on the oil and gas company, on the energy transition. I'm really happy to announce those girls because I have worked with these girls, and I really have a great passion with them, because it's really amazing, really good to see women embracing this future. So I would like to announce Latifo and Madalena Jemusse, and then they will start talking about their lives. They will start to talk about their journey, the projects that they've been working for, and later on they will start presenting their presentation about the LNG. So Nancy and Madalena, the floor is yours, guys. Thank you.
Thank you, Margarido. Thank you, Madalena. Thank you, the audience that decided to join us today. My name is Nancy. I'm currently working as a subcontracting engineer for the Coral South project. I have a bachelor's in chemical engineering from Eduardo Mondlane University. And first of all, I would like to highlight here and thanks MWE that joined these two different countries. Nancy speaking from Mozambique, that is ending the day. Margarido speaking from Brazil, that is starting the day. And Madalena, that is speaking from South Korea, that is actually going to sleep. Madalena, so we'd like you to start presenting about yourself, how you became a chemical engineer, what you're doing now, what is your experience, and then I will continue the presentation.
Hello, everyone. Hi, my name is Madalena Jemusse. I'm a utilities process engineer working for Technip FMC on the Coral South LNG project. Currently, I'm based in South Korea. It's 11 p.m. here. And I know that the other hosts here are also in different locations, but thank God to have these technologies to bind us together in this meeting. So my work basically here in South Korea is to support the commissioning activities. So we're starting with all of the testing of the equipment, all of the processes, and as well making the procedures for the startup of the LNG plant. The construction is almost finished, and now we are moving on onto the commissioning phase. And finally, we're going to go to the operations and maintenance phase, which is basically the department that I belong to. I'm very happy to be here, to be in this presentation. I want to thank MWE one more time for this invitation. I'd like here to invite all of you to enjoy as much as you can. Let's make this a great learning opportunity for all of us. I'm not very experienced in the industry, so I think that I can learn a lot with you guys, and I'll try to share a little bit of what I know. So feel free to make questions, comments, and suggestions. And enjoy the presentation. Thank you.
Well, thank you one more time, Madalena. Thank you, Margarido. I joined the oil and gas industry in 2019 when I participated in an internship in the out-country training program sponsored by the TGS Consortium. And I spent 6 months in South Korea as a hull process engineer trainee. When I returned, I joined an engineering company, call it ETJV. That's where I'm working today. And I joined as a local content officer. And then after 1 year, I shift to subcontracting engineer. So you can see as a chemical engineer, I have now a lot of experience. I was exposed to different departments, and this actually helped you have a really great path in the professional way. Before we start going through the presentation, I would like to highlight that LNG stands to provide massive benefits to society whose thirst for energy is growing rapidly. So taking this in consideration, we decided to prepare this 5th episode, the LNG production, that will have the following concept. We will talk about the LNG concept, as I said, how we can produce this LNG, where can we produce, and what are the applications of the LNG. Starting, I would like to highlight here that natural gas is the cleanest fuel and is very versatile that can use for space heating, cooking, water heating, and has industrial uses, but it's also used as an electricity generation. By 2040, natural gas will be the world's fastest source of energy. So it's important to really understand how this natural gas has been formed, how can we use the natural gas, and that's why we take in consideration in this presentation. Natural gas is basically composed by methane with smaller quantities of other hydrocarbons and was formed millions of years ago when dead animals sucked in the bottom of the ocean and was subject to intense heat and pressure and was kept underground for millions of years. That's where we have natural gas. This gas is normally found in rocks called reservoirs that has little spaces called pores, that keeps the water, the oil, and the natural gas. These natural gas, oil, and water are kept in the impermeable rock called camp rock. So what is LNG? LNG stands for liquefied natural gas, and is a liquid state of the natural gas after being cooled to an average temperature of minus 162 degrees Celsius. And when we are cooling down this natural gas, we are solving the volume problem because we are reducing 600 times, making transportation much easier and expanding the market of the LNG. This LNG can be produced in two types of plants, onshore and offshore. And I will start explaining to you the onshore plant. And here we see the project in Australia. You will see that this plant is normally located in the land, close enough to the shore to facilitate the offloading process. And this plant has 2 liquefaction trains, making a capacity of 8.9 million tons per annum. And the operator is INPEX with Total and another Australian subsidiaries. You can see that this onshore plant normally occupies a lot of space because we need to make sure to respect the environment and the way we produce the LNG. The gas field is called Ictus, and that's how the project came, and we call it Ictus LNG, and it's located in Australia, as I said. It's important here to refer that we need a jetty. The jetty is the portion that we will find in the ocean that is normally used to dock the LNG carriers on the offloading process. The other project is the Prelude. It's an offshore project. You can see that it's very big because it's considered being the biggest floating platform in the world and has a capacity of 3.6 million tons per annum. The operator is Shell and was constructed by Technip and Samsung. This floating platform is normally located in the sea, close enough to the wells, solving in this case the problem of using much space to have an onshore plant. It's important here to say that we will have 2 important units that I would like to explain to you. The first one is the flare. That is this big vertical structure that is used to flare the gas in case of a leak or when we want to depressurize the process. The other portion that I would like to talk about is the turret. The turret is normally the link or what joins the platform with the wells, and this is a fixed structure. And in case of bad environment conditions, this platform can rotate to avoid the damage of the infrastructure, to avoid the damage of the equipment, making sure that the production and the way of operating this floating platform is not compromised. For your curiosity, we have also the Coral South project that will be an offshore plant being on this moment, as Madalena said, constructed in South Korea by Samsung in the consortium with Technip and JGC. This platform will have a capacity of 3.4 million tons per year, losing a little bit for Prelude, but it will be the first LNG ever built in Africa, which makes Mozambique a really great potential to explore the natural gas. Now let's take baby steps and starting explaining the way we can produce actually this LNG that I'm talking about here. The gas, it comes from the wells, enters in the FLNG, in the onshore or offshore plant, and goes to the first unit that we call it the inlet receiving facilities. In the inlet receiving facilities, we have the first separation because the gas comes with a lot of impurities. We are talking about sand, slags, liquids, mercury, and many others. So it's important to remove these impurities to make sure that when we get to the heart of the process, we will only have methane. That is what we want to transform to liquid. After this first separation, the natural gas is sent to the second unit, that is the pre-treatment. And in the pre-treatment, we have a separation of sulfur, carbon dioxide, water, and mercury. These components have to be removed because of the operation conditions on the liquefaction unit. After this separation, the natural gas is sent to the NGL Recovery and Fractionation unit, where we break down the natural gas. We break down in methane and the other components. I'm talking about ethane, propane, butane, pentane, and condensates, that is from methane plus. And these condensates normally goes to a specific treatment, or you can go to a storage that can be after offloaded. The nitrogen, or the NGL recovery, here I'm talking about the refrigerants that will be used to liquefy the process in the liquefaction unit. After this, the natural gas is sent to the heart of the process, that is the liquefaction unit, using the refrigerants that were recovered in the NGL Recovery and Fractionation unit. And after the liquefying this natural gas, and we have the LNG, we store this LNG in the tanks until the offloading to the LNG carriers. All of this that I explained here, it's called process units. And these process units, it's normally required utilities. The utilities here that I'm talking about is water, air, nitrogen, and some other chemicals. If you want to cool down the temperature on any of these units, we need to use water. So water, in this case, we are considering utility. If we want to make an inert environment on the storage tanks, inert environment, why? Because we are sending a substance, we are sending a liquid that is in minus 162 degrees Celsius to a tank that if we don't create this inert environment, we will create an explosion. And to create this inert environment, we inject nitrogen. So nitrogen here is also considered as a utility. If we want to, for instance, in case of chemicals, I'm talking about MEG, that is the monoethylene glycol, that is normally injected into the wells to avoid the formation of natural gas hydrates. That is normally ice. So to avoid this formation of ice, it's important to inject MEG, and then we can extract the gas without problems. I explained to you the basic concept of the project, the production of the LNG. So Madalena, what do you think would you like to take the lead and explaining to our audience about the equipment that we can find on each of these units, the operations conditions, and what are the applications of this LNG?
Of course, Nancy. Thank you very much for this amazing presentation. I'll start by showing here the LNG production process flow diagram. What you see there is the representation of the schemes of every equipment that we have on a normal LNG production plant. You can see that the equipment and the interrelation between the streams of natural gas and many others that I'm going to detail further. But all of this is used basically to show the overall process that we have on an LNG plant. To have a better understanding here, we can compartmentalize this, or we can categorize these equipment into block flow diagrams, starting by the inlet facilities. On the inlet facilities, there you see that we have that equipment that I'm going to talk about there as well. But here, this is the interface between the subsea and the production plant. Then we go to the pre-treatment part, where we're going to treat our gas into an acid gas removal unit, into dryers, and into mercury removal to remove the acids, the water, and the mercury. After this, we're going to separate the components of the lean gas, of the natural gas, which is going to be the methane from all of the others, C2 plus or the other natural gas liquids. Our natural gas will pass on to the liquefaction, which is where the gas is cooled and then liquefied. After it is expanded to be stored in an LNG tank, where it stays there until it is offloaded using an LNG carrier. One thing to consider in this process flow diagram is that this is just a general representation of the process. Does not mean that every LNG plant is going to have the same representation or the same number of equipment or even the same technology. Here, what it is at play, what is considered when we want to design, to choose, and to have a LNG plant is the conditions of the gas that you have, the composition of the gas that you have on the well, depends on the capacity that you want for your plant, and the technology that you're going to use as well. So now we're gonna get into detail into each of the blocks that I've shown here so that we can see how the natural gas stream flows into all of these equipments and units until it is liquefied. Let's kick off by the inlet facilities. On the inlet facilities, we have the gas coming from the well at pressures that vary from 80 to 120 bar. This gas enters here at temperatures with a very high interval there, but that depends as well on the conditions that we have on the well. As you know, as this is the interface between the well and the production plant, this unit can receive also effluent and slags and also fluids which are a result of well operations, such as pigging and the depressurization. I am sure that you have heard about this on the previous ENERGIZED SAGA episode when we talked about the well and reservoir studies or engineering. On these inlet facilities, a very important process is done, which is the natural gas metering. Here we will know what is the flow that is getting in, that is going to go into our plant, its pressure and the temperature. This is very important so that we can make sure that our feed gas is going to have the conditions as per what we designed onto our LNG plant. The separation that happens here is the first one as well, which is a separation of the aqueous phase and the liquid phase. This is done by gravity on a slag catcher. A slag catcher can be represented by this drawing here or this video, where we're gonna have our natural gas coming in that tubular part. The natural gas here is gonna be a mixture of gas, slag, water, and other liquid particles. This is gonna flow through the tube as it goes as per the video, and we're going to see some gas and water particles. Because they are lighter, they are going to flow into the vessel that is on top of these tubes. Here in this part, it's important to note that these liquids, these gases are going to flow into these parts of the baffle here, and then we can have a first separation from the liquids and the gases. The gases will then, after, flow into up here, which will go to the next unit. We have an important thing here that we should mention, which is this part here, which is the demister, which also has a wire mesh which helps to all of the liquids here, the liquids droplets that have gone up, that have been evaporated here into this vessel to also fall down, because what we really want is only gas. Okay, what happens to the part of the slags? This slags, remember, it's just liquids and meg, and it can be water as well, which we have on our wells. This is going to flow through this tube up to the end. These tubes are also used to keep the flow of this, or to keep the volume of this gas in the tubes. We have a valve downstream that's going to control this volume, and liquid and gaseous phases as well. If we have some of them are going to flow upwards through gravity because they are lighter, and will run back to our slag catcher. Before going to the process part, they are going to be as well let down here on this demister. Now we have our gas free from the aqueous phase and the other liquids, which are condensates. We have now to start with the pretreatment process of our plant. We'll start here, our gas called sour gas, because it's full of acids and like the hydrogen sulfide and CO2. So it's called sour gas. It enters at pressures up to 77 bar gauge, and the temperature is not higher than 25 degrees. We need to make sure that it gets in these conditions so as to make sure that hydrocarbons, heavy hydrocarbons, are further separated here so as not to create foaming on the acid gas removal unit, nor in the regeneration unit as well. This gas is going to be stripped of all of the acid, and it's going to leave the column as a sweet gas, which is the gas without these particles, these acids. This is done through a process called absorption process, which happens on an absorption column and with an amine solution, which is going to be regenerated on a regeneration column. The gas kit, where we have the processing of our natural gas. What happens first? We have that first separation on a two-phase separator, where the leaks are going to be separated from the gas. We're going to pass on through a filter separator, and then onto another fine filter separator to remove all of the particulates that we have on our natural gas. This natural gas is going to flow onto the acid gas column, where it's going to flow upwards, and an amine solution is going to enter the column on the top to the bottom. Here we're going to have the contact between the two of them, where amine is going to absorb all of the acids that we're going to have on the sour gas. This is an isothermic reaction. That's why we need to start with the low temperature. And the gas here, which is sweet, without the acid, is going to live at a higher temperature. It's going to be further separated on an after scrubber, and then it's going to flow to be cooled, to be relieved of all of that heat gained through the isothermic process of the absorption that happened on our column. Okay, now the amine, we call rich amine the amine which is full of acids. This rich amine needs to be regenerated to be used again on our acid gas. How does that happen? First, this goes through a flash tank where gaseous phases are flashed on the rich, the gaseous phases of rich amine are flashed, and then they move onto here a filter process. Here it's filtered the first phase to remove the particulates, and then we remove the hydrocarbons on the charcoal filter, and finally we remove the charcoal particles on the after filter. This is processed to remove all of the impurities of our rich gas, of our rich amine in this case, prior it is heated there on that plate fin heat exchanger and go into the steel column. Here, all the acid is stripped using the steam. Stripping process is basically the stream is going to absorb all of the acids from the gas, from the rich amine, and it's going to leave as a lean amine. This goes to a direct fired boiler, which is a heat exchanger. We are putting heat onto it so that it can transform into steam. This same steam is going to flow into this steel column from the top and to be used as a reflux. So this is going to be condensed first, and then it's going to get in there as a liquid. We pass this into an accumulator, and the water that is down is going to be removed from the system, and the acids will also be removed to be further processed in a dedicated facility. This water is going to be reinjected into the rich amine to be further processed in the column once again. Now, on our direct fire boiler, we still have our lean amine there, which is going to flow through that weir, and it's going to be cooled here on the same plate and flame heat exchanger that heated the rich amine. After this is going to be cooled again. As you know, the temperature that we use in our amine gas removal is low, and this goes to the gas skid to remove all of the acid from the gas again. So this is the regeneration process of the amine. Being that said, we have our gas sweet going into the dryer. This is the second step of the pre-treatment, where the sweet gas is going to enter at pressures ranging from 70 to 75 bars and temperatures not higher than 35 degrees. Here, water is going to be removed so as to avoid that this freezes on the liquefaction units where we have cryogenic temperatures. This process this process that goes on in these two dryers is called glycol dehydration with regeneration, but we can also have another technology used, which can be the molecular sieve. So dehydrate is basically removal of water, remove the water. This is done on a dehydration facility where our gas, which has hydrocarbons, has also the water, some impurities, and other gases, which will be further removed on other process. This will all flow on the bottom of the column, and from the top, we're gonna have our glycol solution. This is gonna enter in contacts, and the pure glycol is going to absorb all of the water and finally be regenerated in a process similar to the regeneration of our rich amine to have the lean amine. So another way that we can perform the dehydration process, which is the removal of the water from our natural gas, is through the adsorption process. This adsorption process can be done by inserting some materials onto our beds, onto this part here was supposed to be the piping. This equipment can be, or this material can be alumina types or molecular sieve. What these are going to do is basically trap the water into their surface and let our gas pass through. This is done through an adsorption process. Adsorption process is basically the process that we're gonna have particles, gonna have molecules attaching to the surface of the material, which is your adsorbent, and it's gonna let pass all of the other gas that we need in this case to be free of water. The process that is the last for the pretreatment is the mercury remover. Here we have our gas entering our mercury remover at pressures of about 73 bars. And we need to remove this mercury because this can cause corrosion issues into the pipes or equipment on the subsequent units. So the process that happens here is the same that happens on the dehydration with adsorption process, where we're gonna have a material being on a bed, which is going to adsorb into its surface all of the impurities that we want to remove. This is a rather simple process. We have here a vessel, which is packed here by certain filling, a structure with the adsorbents on it. The gas is gonna pass through it and it's going to adsorb into its surfaces all of the mercury, and the gas is gonna move out in a cleaner state, free of all the impurities. We have now removed all of the impurities of our gas, but we need to be aware that natural gas is composed basically by methane. In this case, as our gas is composed by hydrocarbons, which are molecules that have carbon and hydrogen. What we need is methane, which is the hydrocarbon with one carbon. So the other ones can have two carbons, 3 carbons, 4 carbons, and so on. So on the first stage of our separation here is to separate the methane, which is 1 carbon, from all of the other C2+, which is all of the components which have 2 or more carbons on its structure. This is made through a process called distillation process, which is done on a distillation column. Here we make the first separation where we separate the methane from the other constituents, but these other constituents, which are called natural gas liquids, can also be further separated between themselves to have pure components. These components are ethane, propane, butane, condensate, and in very low quantities, other kind of components like C6+, which is benzene, etc. These make these separations of the natural gas liquids because we can use the ethane, propane, and butane in the process itself to be used as refrigerants, or we can also use that, we can sell that, we can transport that to be used for other applications, like for instance, the gas that we use in our kitchens. I have the condensate also living there, which is also transported as a byproduct, which mixes as well with the condensate coming from the inlet facilities after it has been stabilized, and then it goes to the market to be further processed. The distillation process starts by cooling the gas into a heat exchanger using a refrigerant. Here we make this first cooling so as to condensate the heavy particulate. But to have a very good condensation, we pass this through an expander where the temperature is let down up to -100 degrees Celsius. So we have a cryogenic mixture, a cryogenic liquid, which goes to the demethanizer to remove the methane that we want, which is our natural gas. This happens by putting this cold cryogenic gas from the top of our demethanizer, and this flows down in concurrent with the warm gas, which is going to strip all of the methane out of the column. This is going to leave on the top here, it's called residue gas to turbo expander. This residue gas, in this case here, we're talking about our natural gas, which is going to go to the liquefaction, which before we can put again in a turbo expander here and send to the subsequent unit, which is the liquefaction. What happens with the natural gas liquids? The natural gas liquids can be separated into each component, as I explained before. And this is done on different type of columns, but with the same mechanism, the distillation columns, which can be called the ethanizer, for instance, if you want to remove ethane. What happens basically is you have also a cold liquid coming from the top, going down and going in concurrent, but the warm one, which is going to strip all of the ethane to then being further processed or being used in the plant. The NGL can be sold or sold to the market, or can be stored until it can be offloaded, as well as condensate or other differentiation of components, which means LPG, for instance. In this case, at the ethane, propane, and butane, which are further processed in the fractionation unit. Just for you to see what really happens, what is the feedings, the packings, what we have inside of distillation column. We can have the feed gas inlet coming in a distillation column. This is the debutanizer, which separates the butane from the other C5 mixtures, but this happens for every other mixture. Here, every other distillation process, I mean. Here we have our liquid flowing in the column, and the bottom part goes to a reboiler. It goes to a reboiler so that it can be heated. Here we can use a heating medium like hot oil, for instance, to heat this natural gas so that it can get into our distillation column as vapor. This will flow inside of the distillation column, where you can see we have kind of structures there, which we call plates. The structures can be plates or can be packed beds. The importance of these basically is to increase the area of contact between the vapor and the liquid that we have here. Because if we have higher contact between the two, the vapor is going to take with them the lighter components, and the liquid is going to drag all of the heavier components down. This vapor is going to be partially condensed and will return to the column as a pump to be used as a reflux. A reflux is also a very important part of a distillation column, because this is going to enrich our vapor stream here, as this is going to evaporate, is going to strip as well the light components up, and the heaviest ones are going to go on the downside way. So this is basically what happens in all of those distillation columns. After we have this, we have the separation of the mixture. We have our natural gas full of methane, basically with the majority composition of methane. This methane needs to be liquefied. Okay, so now we have our natural gas composed majorly by methane, ready to go to the liquefaction process, where it's going to be cooled, liquefied, and subcooled so as for us to have our liquefied natural gas. This is a process that happens in equipment called cryogenic heat exchangers. These equipments are cryogenic because they cool, they liquefy the gas up to temperatures which are minus 162 degrees, which is a cryogenic temperature. This is achieved through a process called heat transfer, which means that heat is transferred from one fluid to the other. In this case, the heat is going to be transferred from the natural gas to the refrigerant. The refrigerant is what is going to make sure is what is going to absorb all of the heat so that our natural gas can be cooled and finally liquefied. You might be wondering, how does this refrigeration reaches those temperatures and pressures or the conditions necessary for it to liquefy the gas? Well, this refrigeration goes through a refrigeration cycle, which is basically what happens in our refrigerators at home or our air conditionings, where you have a refrigerating moderator, which is going to absorb all of the heat on the ambient that you want to cool, and then go through a certain loop so that it can always be at the conditions necessary to provide this cooling effect. The refrigeration cycle needs to have the refrigerant entering the heat exchanger, or in this case, the main heat exchanger, at low pressure in a two-phase mixture, which means it's a mixture between gas and liquid in a pressure that is a low pressure. These are the conditions that we need for our refrigerant to be able to absorb the maximum heat as possible from our natural gas. This refrigerant, when it goes through the heat exchanger, it is going to absorb all of the heat from the natural gas and it's going to become a vapor. As it is in a completely vapor phase, we need to go through a compressor so that we can increase the temperature again. What we're doing now, all of the next processes, all of the next equipment that your refrigerant is going to be through, it's in order to have, again, a gas at a low pressure and two-phase mixture. So having the vapor coming out of the heat exchanger, it goes through a compressor where the pressure is increased, but it's still in the gaseous form. So it needs to go through a condenser where the heat here, contrary from what happens in the heat exchanger, the heat here is expelled. Our refrigerant is going to lose the heat to the atmosphere, which can be using coolers, for instance, and then it's going to become a high pressure liquid. Being a high pressure liquid, we needing the low pressure, we need to reduce that pressure. This is done on an expansion valve. Here what happens, basically, this pressure is let down up to the lowest pressures that we need. And we have the formation of these liquid and gaseous mixtures that I spoke about, the two-phase mixture, through a process called flashing. In this case, our gas is going to go through, our refrigerant is going to go through the expansion valve, it's going to be flashed, and it's going to become, once again, in the condition that we need to have our refrigerant coming into the heat exchanger. In this process here, the natural gas is just going to pass by, it's going to be giving its temperature, and it's going to be liquefied as we have our refrigerant in this liquefaction cycle. This heat exchanger can also be explained on this drawing, which we see the natural gas passing on the first part, and then it's separated into two mixtures, one liquid one and one and the gaseous one, which is going to flow again inside of the cryogenic heat exchanger. The pressure is going to be increased, it's going to be reduced to near atmospheric pressure, and then here we're going to have further separation and pump this into LNG. This side here is the refrigerant loop. On the refrigerant loop, we see here our refrigerant going inside of the main cryogenic heat exchanger. Here is going to be expanded to be transformed into liquid as well, and cool our natural gas. The upper part is going to also come back in. It is going to cool the refrigerant itself, and then it's going to be expanded on a GT valve and move back again to the liquefaction. So you see here we have many passes of the refrigerant so that we can cool our natural gas and finally liquefy it to be used further. This gas, after this process, needs to be stored. It is stored on tanks, LNG tanks, which are isolated tanks where the LNG is kept at pressures near atmospheric pressures, and it stays there until we have an LNG carrier to transport it to be further processed. On the tanks, we can see that we have a formation of boil-off gas, which is the result of the evaporation. And this boil-off gas is not discarded. As I explained before, this boil-off gas can be used to regenerate a molecular sieve, for instance, or the biggest part of it can be used as a refrigerant. Can be used on the power generation to power gas turbine generators that are going to give power to all of the processes inside of the FLNG. Our liquefied natural gas is going to flow through the pipes up to our LNG carrier for the transportation. A very special thing happens on the transportation between the LNG from the plant to the LNG carrier, which is the transportation through the marine loading arms. This is a very high advanced technology where we have these steel pipes here are very articulate that are connected. They are going to connect to the pipes of our LNG carrier. You can see that we need to have one good end termination here so that we can connect properly this energy loading arm to the LNG carrier. So this pipe needs to be thoroughly isolated, and this connection needs to be made to make sure that we have no leaks. There is also a system that prevents to have leaks in case of movement of the LNG carrier or the FLNG. If it's moving, we can have a disconnection and we will not lose our LNG to the atmosphere. Well, we have our gas on LNG carrier. The last step that we have now is to transport this gas through a ship, which is the LNG carrier, which is full of other tanks, which guard this LNG. And this is separated either onshore or offshore, where this LNG is going to be offloaded for the further processing. Here, this gas can be used for various applications. And this starts by putting this back into tanks here, where we're going to have some boil-off gas as well, which is going to be used for the plant that is going to regasificate this LNG. Okay, let me go again. So here we have this LNG flowing here onto a facility which is going to regasify the gas. As you know, the gas is at minus 160 degrees. So this can be used to cool also the GGG cooling loops and the other big equipments that we're gonna have on the plants where this is going to be processed. So this can be the natural gas, when turned back into natural gas, can be used to be transformed on other liquids. One example is the technology that is used called the GTL, which is gas to liquid, where we have this natural gas being transformed into syngas and finally being converted into liquid gases, liquid fuel that can be used as well for other applications. But the biggest part of this LNG, regasified LNG, is used for the power generation. So this is going to move onto the pipes, and this is going to get to your homes, to your houses, but it's going to provide all of the heating and all of the energy needs that you need to develop our world. So that is all regarding the LNG applications. And follow us for further episodes. There is the next episode that we're going to talk about the production and the marketing of this LNG in further details. Stay tuned to our social media, and you'll be able to see what is the next step on the LNG value chain. Thank you very much, guys. If you have any questions, comments, I'm gonna pass on the words to Margarido. Thank you.
Thank you so much, Madalena. Thank you so much, Nancy, as well, for sharing your knowledge, your presentation, and all of this with us. We have some questions here. I guess we can move right now to the Q&A. But before moving that, I would like to read some of the points here addressed to us from Venilson Nyabomba and Antonio Jupela. They really enjoyed the section, and they talking about the process. They say that the process is beautiful, and the other points is the presentation was very illustrative, and it makes and easier to understand. So the first question, it's from Dinoka Quive. She would like to know at what temperature this refrigerator is done. I guess she's talking about the refrigeration of LNG. She would like to know at what temperature this is done. So I don't know, Nancy can answer this, please.
Well, thank you, Dinoka, for your question. Normally, this refrigeration process occurs in an average temperature of minus 31, 34, and goes up until minus 132 degrees Celsius. That's what Madalena was explaining during the refrigeration and the NGL recovery process, and also in the liquefaction process.
Oh, thank you, Nancy. Thank you, Nancy. Moving on, the next one is from Venilson Nyabomba. Thank you, Venilson Nyabomba, for your question. You would like to know, in the first steps of the LNG process, we have the separation of gas and impurities. Where do these impurities go after the gas is removed from that combination?
I think I can answer this one. On the first part, where we have the acid gas removal, we're going to have the sulfate, the hydroxide, the sulfate hydroxide, or the acids, and the dioxide, the carbon dioxide, also to be removed on this part. These impurities are not used on our plants, so they are normally further processed on other facilities, which can be a process of a thermal oxidizer, or can be also disposed in a well-controlled way. As for the mercury, this is also treated on design facilities to treat this one so that it can be disposed finally in an environmentally safe way to the disposal facilities.
So moving on to the next one. The next question is from Antonio Jopela. He says, by looking at the overall process flow diagram, which section is the most critical or sensitive for the plant's operation, and why?
Process flow diagram, I think I'm going to answer this one as well. For this case, as you can see in our plants, all of the pre-treatments that we do, all of the compositions, changes that we do when we remove the compositions of the natural gas liquid, all of this is in order to have our natural gas free of impurities and free of the other components so that it can go to the liquefaction. So everything is done having the focus on the liquefaction, because it's the heart of the process. It's where we have our natural gas really being liquefied and becoming the liquefied natural gas. This is a very critical process because we have to look at a lot of variables. We need to look at the composition of the gas. If we have any of the impurities that I've spoken about before on there, it can cause serious problems to this main cryogenic heat exchanger, which is a quite expensive equipment. If we have freezing there or a blockage there, it's going to be a little bit of a problem. So all of this pre-treatment and the separation of components is to make the liquefaction a smooth process. This is the most critical one, where we should observe all of these little variables to ensure that we have our liquefied natural gas and the correct composition and conditions to be used on further processes.
Oh, good one. Very done, Madalena. And
thank you.
Sure. Actually, I knew the answer, but I just waited to you to answer this one.
It was a really interesting question.
It was so interesting.
So you should be also a chemical engineer, Margarido, right?
Yes, I can do that actually. So
well, yeah, we all can actually.
Exactly. So moving on, we have a lot of questions actually right now. I will read them right now. The next one is from Adriano Waeka Jr. He would like to know that the boil of gas occur during the loading of the LNG tankers as well. Are they be recovered there as well, or maybe similarly to the plant storage tanks?
Oh, that's a really interesting question.
Exactly.
Adriano, thank you.
Yes.
Yeah, do you want to answer, Nancy?
Yes, I can. Thank you, Adriano. Indeed, it's good to see that we have here the support of our colleagues. And answering to your question, Adriano, yes, we have also the boil of gas during the offloading process, because the natural state of this LNG is gas. So when we have a decrease of temperature, in any case, the liquid will tend to become again gas. And that's why we call it boil of gas. This boil of gas is also recovered and used inside the tanks when we are offloading from the LNG to the plant, or when we are offloading from the plant to the LNG. I think I answered well your question.
Sure you did, Nancy. Thank you so much. Moving on, we have actually interesting question because it's related to the energy transition that we are looking forward to it. And it states, how does LNG affect the environment?
That's a really good question. Who did the question, Margarido?
Sorry. This question is from Zephanias Shumane. Thank you, Zephanias Shumane.
Thank you, Zephanias, for this question. Indeed, we are in an energy transition period. It is important to look at this LNG as a sustainable way to the environment. And normally we try to produce this LNG in a better way to avoid destroying the environment, to avoid the waste in the ocean, to avoid as much as possible damage the environment. So all of the facilities, it doesn't matter if it's onshore or offshore, they try to follow the laws, the in-country laws of the country where the project will be installed. And normally they look for the noise. We are talking about the equipments. They try to look to the impact if it's an offshore plant. They are trying to look also at the threats on the aquatic environment. So basically LNG comes to help us having this sustainable environment and also helping the energy transition itself.
Thank you, Nancy, for answering that. The next question is from Manuel Balanza. He would like to know what is done with the condensate that is separated in the slag catcher. Is there any further treatment for this condensate?
On the slag catcher, we're going to have the separation of the natural gas and then the other liquid phases. This is a really, really interesting question. Thank you, Manuel Balanza. The condensate and all of the liquids are going to be further processed, yes, in another unit that is actually part as well of the LNG plant, but it's just not on the mainstream of the natural gas process. On the condensate, we're going to have also a separation, a vessel like the slag catcher, a three-phase separation vessel, where we're going to separate the entrained gas, the condensate, and the other aqueous phases, which is the formation water, which comes from the well. And then each part is going to be reused onto the system or disposed of. For instance, the off gas that comes from the condensate stabilization, which is where we separate these three components, and then it's going to be joined to the boil off gas and also be used on the generators. The condensate can be stored as well in the LNG facility and then being offloaded and further processed onshore. The formation water as well is processed on the facility as well. It's one of the utility system, and then it's disposed of in a proper and controlled way. So I hope this answers the question.
I guess so. We can move on. The next question is from Zephanias Shumane. He would like to know about the operational integrity of the LNG companies or risks, about the regulations and also the organization that can deal with this LNG. Let me try to clarify this one. He would like to know about the integrity of the LNG. Is it okay to work with the LNG, for example, in our country? And what about the regulations? Which regulation that we need to have in account there, but when talking about the LNG in Mozambique, for example, and also the industry organization, which industries that can deal with the LNG?
Okay, Zephanias, thank you for your question. So let's start portion by portion. The first one is the integrity.
The operational integrity of the LNG risks.
Okay, yes, the LNG itself, in terms of being dangerous, is not that considered because of the conditions that is built and prepared. And also the way we deal or the way we try to produce this LNG, we make sure that we follow all the LNG rules, all of the standards to produce this LNG. In terms of regulations, normally it's important to have an institute in country it depends really from country to country. In Mozambique, yes, we have one. So all of the project that wants to be built in Mozambique has to follow these rules. Normally it's the government institution. And in terms of industry organizations, we can use LNG in almost everywhere. We can use LNG as fuel. We can use LNG in energy. We can use the LNG in the products that we use. So there are a vast industry, I will say, in terms of uses of the LNG.
Thank you, Nancy, for answering this. Moving on, we have João Matos. He would like to know what are the advantages and disadvantages of using LNG compared to the renewable energies, the hydroelectric, biomass, and the solar, and so on. You guys are laughing. I guess this one is so interesting to you.
Actually, when we were preparing the presentation, we were thinking the same thing, trying to avoid this misunderstanding in the renewables and the LNG sector. So yes, we are talking about renewables. Yes, renewables is important because we will have the sustainable development of a country, but we have here to look the LNG as a solution to the market, as a solution to the economy development. So it's important to a country to have different sources of energy. So LNG comes to be the solution of these many sources of energy. And the first thing is we will have renewables, yes, but we can also use LNG to be sustainable and be a balance between renewables and the LNG sector.
Good. I like the answer. Yes. So thank you, Nancy. Thank you, Nancy. Moving on, we have Zephanias Shumane. He would like to know, how does LNG regasification work? I guess for this one, we will need to show a slide, or maybe try to answer him by talking, maybe. How does LNG regasification work? Sorry, Madalena. You can move on.
Okay, no problem. Thank you, Zephanias. That was the name, right? Margarido?
Yes, it's Zephanias.
Okay. Thank you. That's a very interesting question. The focus of the presentation today was the LNG production plant. So we went through all of the steps that we have to until we reach the natural gas in a liquefied phase. So the regasification is a process that it's done, which is basically to turn our liquefied natural gas back into the gaseous phase so that it can be used. Because we need to remember that the main objective or the main reason why we liquefied our natural gas was to facilitate in the transportation parts because we have this big reduction of volume, and also as this is transported at atmospheric pressures, it makes the process a lot more safer. So this is a regasified, which basically is a process of inverse of the liquefaction. The liquefaction, we remove the heat from the natural gas. On the regasification, we put back heat into it. We can use that in a sustainable way, but by using the liquefied natural gas to cool certain processes that we have in the regasification plant. For instance, we know that if we have a power generation, we need to cool some parts of we need to have a cooling system for these generators that are going to produce electricity. We can use this LNG to cool for the cooling processes there. It's going to be heated, and this can be reinjected into the process for a part of the power production, where we're going to have this gas burned to produce energy. So it's basically increasing back the temperature and moving on to the next steps of processing of natural gas.
Oh, thank you, Madalena, for answering this. And moving on from Vania Coutinho, she started with a compliment. Hi, everyone. First of all, let me congratulate the ladies for representing the women force within the source or the sector. She would like to hear from you ladies what could be the benefits of LNG in our society, in Mozambique, for example.
Vania, for your words. It means a lot for us, and this just shows that we have the support of every woman in the sector, and also we can be the voices of these women in the sector. Your answer goes aligning with what I explained before and what was Madalena explaining right now, that LNG is basically a solution to transport the natural gas that we have in the fields. So this LNG will help the growth and will help the development of our economy, especially in Mozambique, because you can see, or you could notice that we are being on the news in a way of natural gas, not the bad things. I'm talking about here the natural gas. So it will really help us development, because now we have the opportunity to be on these projects. We will be the future makers of Mozambique. So this LNG is really helpful for all of us. It will bring a lot of women like me, like Madalena, like men like Margarido, that supports the woman and also supports the growth of the energy sector.
Thank you, Nancy. Thank you for this answer. Moving on, João Matos said he has another question, actually. What advice would you give to the final year students of the chemical engineering course who wish to enter this area? Let me stand this, João, and not only for chemical engineering course, maybe for all the engineering course, which advice that you can give us in order to enter this area? This is a very good one. Thank you.
This is an amazing question, actually. I think this is going to bring a lot of value here, and a lot of people are going to benefit from this. My advice, okay, I'm going to talk as a woman first, because we are MWE, but this is applicable to men as well. But we need to emphasize this part of the women, of course, because we still are in a lower number or fewer number compared to men, that it is possible to do engineering, to do chemical engineering or other types of engineers, and really being involved in all of this LNG value chain. One good advice is, first, you need to be connected to all of the platform, or to some of them which share news and give the perspective, different perspective. You need to be connected to good programs like ENERGIZED SAGA, to have a little bit of knowledge about what happens here, so that you can know what are the players, what is a project, and how this process is done, so that if you go to an interview, you can already be one step ahead. One simple thing that I would say as well is you need also to work in communication. LNG industry speaks English, unfortunately. This is the phase that we are now. We are starting as well to get into this as Mozambique. We're starting to get into being one of the players of LNG, and who knows, we can have Portuguese as well. But as of now, this language is really important, because we have a lot of materials, a lot of articles in English, which will help you understand the LNG value chain overall. And try always, it's no miracle. It's just, persistence. You put yourself in the right environment, and you're going to get there for sure.
That's for sure, Madalena. But I would also like to add that don't be afraid. Don't be afraid to try. Don't be afraid of failure, because that doesn't mean that you always get good things. My career started in a bad way, but look where I am today. I'm in an engineering company. So it's good to don't be afraid. Don't be afraid to try. Don't be afraid to speak. And communication also is a very important tool for us as engineer, because normally as an engineer, you just think draws, you just think pipes, heat exchangers, wells, etc. But you have to communicate with others. And this LNG sector is not only for chemicals engineers, it's for everyone, because LNG is a multi-sector that we need electricians, that we need mechanicals, that we need constructors, that we need anything that you can imagine to build a platform or to build a project. So stay connected to all of the associations like MWE. You will see a lot of opportunities. You will be able to join this industry as soon as the light comes to you, I will say.
Yeah.
Oh, thank you, ladies, for answering this. I guess this will bring us much value in Mozambique, for example, as we have many resources there that we will try to discover year to come, and it will be a pleasure to have as much engineers, women and men working on this project. So thank you, guys. So let's move on. Elton Shisaki, he says, firstly, I would like to congratulate the great speech from ladies. I'm not working in energy area. My question is, what is the real impact in the environment after all the resources end up, especially in the sea?
That's a tricky one. Very interesting.
Yes.
Elton Shisaki, really good. I'm really enjoying this discussion here. It's not really spoken as much as the LNG production, the construction of the LNG plants, construction of offshore floating facilities. Normally we don't see many articles about what happens after the gas ends, after 25 years, after 50 years. But basically, it is part actually of the engineering of the project to have the procedure that you're going to have for the decommissioning of your facility when it stops working. For some projects, there is an agreement that is done with the government that the contractors in this case are going to operate the gas. The operators is going to operate the plant that's in a certain stage, and then they pass on to the country, and then we can further process it. Another way is to completely decommission the facility. We remove everything. We start by disconnecting every piping that is in there. We're going to have another session, I think, another episode, which we're going to speak about all of the connection that we have from the subsea up to the offshore facility. So all of these pipes can be easily disconnected, can be removed. All of the subsea the subsea production systems there can be removed and leave the area back to the initial state. This can be done. It's one way also to protect our environment, because really what is the most thing that we need to keep in check here in line is that we want, yes, bigger resources, but we cannot compromise on the environmental part and on the sustainable part of our energy processes.
Oh, great one, Madalena. Thank you for the answer. We still have some questions actually. That means the presentation was so good to everybody, and they are really interesting to know the whole process. Will Zimari Macau, I guess it's she wants to know, going through the João's question, I would like to know what other courses and which important to reach our curriculum to enter in this area with success. She's trying to extend what I did actually. She wants to know which courses that people can do in order to enter in these areas with success.
Thank you. It's Wills Murray. I think we are saying correctly your name. That's a really great question. As I said before, this industry doesn't work only by engineering. We have what we call human resources, we have finance, we have procurement and subcontracting, and we have also the engineering. So in engineering, we are talking about chemical, mechanical, electrical, instrumentation. So you can have a wider idea of what type of engineer I'm talking about. In terms of finance, we are talking about people that have a background in finance, that people that have a background in management, people that know how to deal with tax, with government laws, and etc. In terms of human resources, we are talking about people that will work with training programs, recruiting people that will make training programs for the employees, or people that actually be the relationship between the management lead or the management line and the employees. So you have opportunities in each of these sectors. It doesn't mean that if you did chemical engineer, that is my case, I did chemical engineer, but I entered in this company as a local content officer. Local content officer is basically the ones who engage with stakeholders. After being local content officer for 1 year, I shift to procurement and subcontracting engineer, and now I'm dealing with companies. So I have a background in engineer, yes, as a chemical engineer, but I'm working in another fields that allows me to grow and actually have a really good experience and career path.
Oh, thank you. Thank you, Nancy, for that astonishing answer. Moving on, Zephanias Shumane has another one. He would like to know, how do you handle with LNG hazards? I guess this one is related to the process facility. When we try to process the LNG, when we try to produce LNG, we have so many hazards there. So he would like to know, how do we handle with these ones?
Hazards.
Yes.
Okay. Stephanie, it's very interesting question. There are a lot of hazards really on the LNG plant and on offshore facility mainly. But one thing that I can say is that on especially on offshore facilities, the safety management is really a big thing. It's really something that people look at. There are always procedures. There are always means. There are always trainings, HSE trainings that ensure that people can be in the safest condition. The design of LNG plant itself, we consider all of these means that we can have to protect the people that are in there. We got all of the equipment in the most part of the facility, where if there is any emergency, you can escape by the lifeboats that we have there. We have a lot of equipment scattered throughout the FLNG or throughout the facility that you have that can protect you. This is the ultimate level of protection, which is the personal protection, but we also have other designs on our facility to protect for an eventual situation. We have, for instance, we have fire zones, we have places that we can segregate if something happens in that area. The design takes account also the safety concerns and the safety conditions that we have in our system. We have controls as well in every process to control the overpressure, control leaks, and all of these things. So safety is something really that it's really engineered on this project to ensure that we deliver the LNG in the most safely condition possible.
Thank you, Madalena. And moving on, we have another one from Ines Yolanga. He first says, congratulations for the presentation, girls. As women in any industry, still overwhelmed by men. So what kind of challenges have you faced to be where you were? And what advice would you give to others as women?
Well, I can answer. Okay, you can go, Nancy.
Thank you, Nancy, for the question. It's really an interesting question because yes, we are women. Yes, we are overwhelmed by men. And the first challenge here is that all of the points are turned around to us. Like we are women, yes. If she's capable to do that, if she has the ability to do that, can she work under pressure? So basically, what we face here is just trying to show that we have capabilities, that we have the knowledge, and that we want, yes, to be in this industry. The advice that I will give is that speak up, don't be quiet, show that you know, show that you can do your work so you can have a seat at the table, so you can be in the leadership roles, so you can be an inspiration to another woman. So yes, we are less. Yes, we face challenge, but that doesn't mean that it's impossible and you cannot do it.
Sure. Thank you, Nancy. This is why we're here. This is why we're doing this type of webinars. You know, we're trying to get as much attention of women, specifically in this industry, as we want to make them leaders, make them the future of the energy also. So this just we're doing. We are trying to empower the women for this world. So very done, Nancy. So moving on from Vanessa Valenti. She says, first of all, I want to congratulate all of you for this presentation. I want to know when can we find training programs about the oil and gas industry?
Thank you, Vanessa, for your question. To be practical and realistic, the way that you can find this training is knowing the projects that you have in Mozambique. Let's talk about Mozambique. Here we have 2 projects. So the first thing you have to do is to be connected to these projects, to know what are the constructors, who is the operator, when the project will start, how is the going phase of construction and building the project. After that, you will be able to see these opportunities because yes, it's a new industry in Mozambique. And yes, we are here trying to have a manpower capability. So all of these projects has an umbrella that we call it local content, and is part of the project to train these people. So if we connected to these projects, you'll be able to find these opportunities to be trained.
Yes, thank you, Nancy. We still have 3 minutes left, right? So another question from Yasser Blound. Actually, he wrote a long statement here, but I will try to resume it. And he would like to know, how did you start in this career, the process? When did you enter and how did you join the oil and gas company or industry?
In my personal experience, I joined this company, the oil and gas company, after I graduated. After graduating in 2017, I think so. I joined the company that I'm working on now, Technic Energies, and there I got on through a selection process because this LNG project always bring this local content part, which they always have a program to employ and to give opportunities and to train the locals of a country that has these LNG resources. So I was part of this process. I was able to travel to Paris to have a training, a 6-month training, where I could learn with the engineers there how this plant is done, what are the calculations behind it, what are the considerations to be taken. And from that, you will have you put yourself in the position where you can have a contract with one of the companies, and from that just start with your adventure into the oil and gas industry. So yeah, this is the way that I got involved.
Yes, thank you, Madalena, for your insights. We just move it out from the questions. All we have right now, the compliments. There are a lot of compliments. I will read some from Zephanias Shumani, for example. He says that he's delighted with so much wisdom that's coming from you. And also João Matos, she says, congratulations on the presentation, Nancy and Madalena, and thanks for the responses. Also, Milena Buana, she says, I'm very proud to see that we have women with brilliant minds. Thank you, all of you guys. Thank you for the compliments. Just to close this section, I would like to hear from you, our speakers. What is the feeling? What you can tell us, to just a few words to close this session about your feelings in this work for oil and gas industry, to be part of this energy transition that we are seeking in these all times.
Let me start. I decided to join this company or this industry because engineering is a field that has less number of women. So I was ambitious enough to say, I want to go to the difficult things and do engineering. When I joined the company, I was well welcomed, I will say, because I have two great bosses. One of them is a woman and another one is a man, and they both have different mindsets. And they gave me opportunities to show my abilities to do the work, to show the knowledge that I have, to show the way I organize the work, to show the delivers that I can make. And also they try to flourish all the things that I think I didn't have. And this flourish made me say that now I want to call for other women. Now I want to show that to other women. Now I want to show to other men that we have a space for all of us. You just have to find your path. You just have to find your way. So the way I'm feeling now is that I'm capable of inspiring another woman, another man, and to show that is not impossible to be an engineer. That is not impossible to be. It doesn't mean if you want to go to LNG sector, I will say the energy sector itself, because we have a lot of opportunities in the energy sector. But I will say that now I want to, from 10 years from this webinar, today is 13th of May 2021, in 2031, I want to find someone that said, Nancy, look, I participated on the LNG saga. I was energized by you. And today I'm able to call for other movements. Today I'm a leadership. Today I'm a manager. So that's why I want to feel from 10 years from now that this saga, this opportunity, call another woman or call it another man.
Oh, thank you.
Yeah, well said.
Yes, go ahead, Madalena.
Sorry, Margarito. Yeah, very well said, Nancy. She said everything that I was also thinking about. This LNG industry has a lot of opportunities for everyone. I mean, everyone, for every area. We have space for engineers. We have places for also people that are not engineers to occupy also very good positions, very good leadership position, and advance into trying to make our country one of the big players on this LNG sector. One insight, one insight here that I would like to give, just to reinforce what Nancy said. Just go ahead, guys, try, put yourself in the place that you can have this opportunity, and let's do the most for our country. It's our LNG, and we can do it better than anyone if we try. That's it.
Wow, very well said. Thank you, ladies, for answering. I felt the joy inside of you by your words, and it's really, really fantastic to see you growing in this industry. Thank you all. I guess that's the end of everything right now. Here, just small compliments from Sila, for example. She says, such wise words, Nancy, Madalena. Woo! There's a lot of things here in the chat. And also Constantino Andre, he says, congratulations, Nancy and Madalena, for the enriching lecture. And also Nea Albrino, she says, great presentation. Zephaniah Schumann as well, he says, very great presentation. And also Vanessa Valente, she says the oil and gas industry, it's very fascinating. Beautiful presentation, guys. And also Dinoga Quive, she says awesome presentation and powerfully women. So thank you, everyone. Just a few words. Thank you, everyone, for attending this meeting. We are looking forward to host you again for the next section, actually. And also, if you missed a line, if you missed the spot on this presentation, you will find this one recorded next week or maybe 2 weeks later. And you can see there, you can really look after this one. You can go there to learn as much as possible you can. So that's all. Thank you, Nancy and Madalena, for being our speakers today, and wish you all of the best on your career and job also. May you lead the next leaders also for Mozambique and to empower the women in this category. Thank you so much, guys. And that's all. Thank you.
Thank you, Margarido.
Thank you, guys.
Thank you, guys.
See you next time.
Bye.